Good morning, students. Can you all see the screen? Can you hear me?
Yes, sir. Yes, sir.
All right, good. All righty. So we're going to be doing some revision work today with the coordinate geometry. Today is the last day for coordinate geometry, actually. With respect to the class and the program. Next time we see coordinate geometry will be in revision. Even though we'll be applying coordinate geometry in the next topic of linear programming. And that's the reason we had to do this topic first. I had to do this topic prior to doing linear programming. All right, so I'm going to go through this class activity that we did one more time. And then I'm going to practice some of the questions that I gave you to do. I saw the solutions coming through. They were generally pretty good. Versus making a few errors here and there. But that's how it is, progress before perfection, right? So try the question and make a few mistakes. I'm going to go through it now and learn from your mistakes. There are the questions they can still ask. All right, so that is it. All right, so on the screen here is what we did in the class activity the other day. Question gave us 2 points, A and B. And then they asked a number of things relating to the points A and B. All right. And these are the normal things that they'll ask in a question, exam question, but no exam question will be this lengthy. I can promise you that. And you should notice that from the past paper question that I sent. All right, you get a feel of the level of difficulty of the questions. Not very difficult. All right, so let's go. So A is a point -1, 5. And B is a point 5, -7. I can tell you from now, once you see these negatives, you have to be extra careful. Remember, most mistakes are made with a negative sign. A lot of people doing the right thing, but getting the wrong answer because they're not handling the negative sign well. So it's something that we need to focus on and practice. All right, so the first thing we wanted here was to find the length of the line. All right, and that basically comes down to a formula that was derived from Pythagoras' theorem, and it's a must-know item. And as I always say, you're not going in the exam room to figure out stuff. The more things you know, the better. So you need to just know these things before you go into the exam room. There will be no help in the exam room for you. You have to go in there armed with the knowledge of these things. So whatever it is you have to do to ensure that you know the things, you do it. Get a flashcard, you write down the formula and so on. And you memorize them, or you practice with them, or you write them down a lot, 20 times, until it's basically in your head. All right, so let's go. So the length of the line AB comes on to a formula, which is square root of the difference in the x value squared. I'm gonna write diff x. I have to square it plus the diff y. I have to square that as well. Comes from Pythagoras' theorem. So it's like you have the line, and here is diff x, difference in x values. And here is this diff y, difference in the y values. And you're trying to find this length AB, trying to find this length. And so we're using Pythagoras' theorem. So this length squared becomes the square root of this side squared plus that side squared. All right. So basically that's what it is. All right. So let us put the values in. You have to be careful. So this becomes equal to the square root, the difference in the two x values. So these are the two x values. I'm going to write them in red for you. So these are the two x values, this one and this one. Taking the difference of them, the difference of the x values. All right, coming inside here. So what I want to do this x value minus this x value. So I'm going to subtract it this way. And so it is 5 minus, this x value is a -1. So it becomes 5 minus 1, a -1 squared. Plus, I'm going to take the difference between these two y values now, and I'm going to subtract it this way. Some persons would have subtracted it that way. It don't make a difference because you're squaring the result anyway. But I'm going to subtract it this way. So I'm going to do the -5, the -7 minus 5. So -7 is this y value. And I'm subtracting this y value of 5. So it's -5. And don't forget to square it. All right, go back for the blue. So this then becomes equal to, the minus here becomes a plus. So this works out to be 6 squared. 6 squared plus. This is -7 and -5. They add to -12 in the bracket. A lot of persons, you're leaving off the bracket and putting the square here, and then end up putting -144, for example, and run into problems. You're squaring the entire value, so you put a bracket around it. All right? This works down to, this becomes 36. And when you square this -12, you get 144. And then the 36 and the 144 is 180. So this becomes the square root of 180. You could work this down further, but I was okay with you leaving this as an answer. But one key thing is that you have to put the word units, because the unit of measure in coordinate geometry is units. The unit of measure in coordinate geometry is units. Length must have a unit of measure, whether it's centimeters, meters, inches, feet. In coordinate geometry, unit of measure is just units, all right? And that is it. So that is the answer for the first part. The square root of 180 units. All right, so that finishes the first part for us. The next part we wanted was here, to find the midpoint of AB. All right, so again, that's just a formula that we're going to be using for part B, and we treat the midpoint like an average point. That's an easy way to remember how you get it, by treating it as if it is an average point. So I say that the midpoint I'm going to give it a capital letter M, is the average of the x values. I'm putting average x and the average of the y values, AVGY. So you're averaging the x values and you're averaging the y values. Let me copy about the points down here. So we have them on screen. Let's copy these back down here. Put them right here. So again, these are the 2 points. And now I'm going to take the average of the x and the average of the y. So this point M, the midpoint M, and I'm going to go for the red again. These are the 2 x values. I'm taking the average of them right here, the average of them. So it is -1 plus 5. And when you're taking average of 2 values divided by 2, add them and divide by 2. Then I'm averaging these 2 y values. That's 5 and -7. So it is 5 and -7 divided by 2. You might think, okay, why not put a plus here? Why not say 5 plus -7? So you're averaging the 5 and the -7. The same thing, because this plus minus right here is the same as minus anyway. So we don't have to do that. So it's 5 minus 7 divided by 2. And some persons were leaving off these brackets. It's a point that you're finding, you have to put them on. And you always simplify your values down to lowest terms. So if I simplify this, this becomes a 4. 5 minus 1 is 4. I initially get 4 over 2. This is 2 minus 7, that's -2 over 2. And some persons were leaving this. No. Once the values can be simplified, just simplify down to lowest terms. This is 4 divided by 2, which is just 2. This is -2 divided by 2, which is just -1. So that is the answer. That is the midpoint right there. All right, don't put answer on these. So this is an answer right here for the first part. And now this is an answer for the second part. for B. All right, everybody good so far? So far, so good, guys?
Yes, sir.
All right. So finish the first two parts. Let's go on now and do part C, which was to calculate the gradient of the line. Remember, gradient is the ratio of the rise to the run between the 2 points. All right, simple as that. The rise, remember, the difference in the y values. The run is the difference in the x values. I'm going to set it up like this now. I'm going to calculate the gradient. The symbol for gradient is common M. And because it is the point, because it is the line AB, I'm going to put a subscript AB on it. This means gradient of the line AB is equal to rise over run between the 2 points. And the rise is the difference in the y values. I'm going to write diff y over the run is the difference in the x values, diff f between the 2 points, diff x. So let me write down the 2 points again and show what we are focusing on, what is important. Come on, come on, come on. Yeah, so these are the 2 points again. All right. So I'm taking the difference in the y values. So I'm doing this calculation. Right. So the gradient of AB comes equal to, what are the 2 y values? These are 2 y values. I'm taking the difference between them. And I'm going to take the difference between these 2 x values for the run. What is important when calculating gradient is that the direction that you subtract for the difference in y, you have to subtract the same for the difference in x. So either I'm subtracting this way or I'm subtracting the values this way. I have to remain consistent with the way that I subtract them. So let's say I'm going to do this point minus this point. I'm going to do my subtraction this way. My difference in y values are these. These are my 2 y values. I'm taking the difference. Right? And as I said, I am subtracting, put an arrow on it, this way. So this point minus this point. So it becomes this y value minus this y value. That's the difference in the y values. It becomes -7, that's this y value, minus this y value is a 5. So -7 minus 5 divided by, I have to subtract these now again, this way again for the x. These now are the 2 x values. And so it is this x value, which is a 5, minus this x value is a -1, not 1, a -1. So I'm doing 5 minus a -1. This minus minus here is equivalent to a plus. So let's put a plus right there. So this is like 5 plus 1. If I simplify the values, I'm going to get -7 and -5 is -12 divided by, this will become a plus, is 5 plus 1 is 6. Again, some persons were leaving that. This can be simplified because 12 divided by 6 is 2. And so the gradient of AB, if we do -12 divided by 6, 12 divided by 6 is 2. And so that's a -2. That's the gradient of AB. And that's our third answer right there. Gradient of AB is a -2. But good so far?
Yes, sir.
My time. And all that you got it right in the class already, but more maths equals better maths, just revision. All right, let's go back to it again, because we want to cement these things in the brain to a point where we don't forget it again ever. All right, that's what we want to get to. We want to master these things. All right, we're going to part D now, which wants us to calculate the equation of a line AB. All right, we want the equation of AB. So let's do it here now. Equation of AB. For part D, we want to get the equation of AB. Now, the key thing to remember about finding an equation is that we need to know 2 things. Find the equation of a line, we need to know 2 things about it. We need to know, let's write it out, we need to know two things about the line. One, we need to know the gradient, which we have. The gradient of AB, we just worked it out a while ago. It's a -2 right here. So we need to have a gradient. Next thing we need to get the equation is a point, a known point. A known point means that you know the values on the point, know the coordinates, x and y value. You need a known point. In this example, we have 2 points. We have A and we have B. We only need one. We need one known point, unknown point. But we have 2 points, so we can choose use either the A or the B, whichever one. Right? We have 2 of them. We can choose use this one as our known point or this one as our known point. Any one you use, the answer is going to be the same. Let's say I've decided to use the A point for no particular reason. I've just decided to use the A point. So I'm going to use the point A as my known point, coordinates -1, 5. So this is my gradient, that's my known point. I can now write the equation. Now the equation of a line, using what I like to call the BFF formula. So we can use it, y equals mx plus c to get it. But I tend to use this when I know these two things, gradient and the y-axis intercept. In this case, I don't know the y-axis intercept. I have the gradient and a point. And so I'm going to use what is really called the point gradient form. The point gradient form for the equation of a line. And it is the equation using the point gradient form is y minus the y value at the point. And so if using A, I'm going to write YA equals the gradient of the line AB into x minus the x value at the point. And the point we're using again is A. So I'm going to write XA right here. So it means that this value, the y value at A, is this one. The gradient is this -2. And the x value at A is this -1. And those are the 3 values that we're going to be substituting in this equation. This x and y right here, they will remain in the equation because they represent all points on the line. It's called a general point. So we leave them in there to see what the connection between x and y is for all points on the line. That's what the formula of, that's what the equation of a line really is. And it is an equation that is used to calculate coordinates of points on a line. Points on a line will satisfy the equation of a line. Coordinates of points on a line will satisfy the equation of a line. So we want to leave these two in there to represent all points on the line. So substituting in the values now. So it becomes y minus, that's y minus. We're putting in this y value, which is, as I said, a 5. Because y minus 5 equals the gradient. Gradient is this -2. The gradient of a line that we want, -2. Into, that's this bracketed term now. Again, I will put the general x here. X minus, that's x minus. And then this x value now is this -1. X value at A is -1. So I have to put x minus and -1. And then this minus minus here becomes a plus. All right, so once you see minus minus, it becomes a plus. So inside is almost, it's basically x plus 1. Inside this bracket is basically now x plus 1. All right, that's what it is. So this basically now a matter of simplifying this down and writing it in the standard form, y equals mx plus c. It's nice to get y alone as the subject. But first, I'm going to expand this bracket and I have to be careful with this -2. All right. So I'm going to write this back as it is first. Y minus 5 equals -2 times x is -2x. And then -2 times this, remember now that's a +1. That's -2 times +1. That becomes a -2. All right. So that's a -2. Continue. A lot of people make a mistake. A lot of people have this, and then do the wrong thing. We need to leave y as a subject, so we need to transpose this -5. When this -5 come on the right side, it has to become a +5. We must start doing this now. Remember, it is the same as adding 5 to both sides. And then this negative 5 and 5 wipe out each other. And then this positive 5 remains to work with this negative 2. That's how it is. But the shortcut way to do that, adding 5 to both sides, is to say we take this negative 5, transpose it to the next side, and change the sign to positive. That's a shortcut method. But theoretically, what you're really doing is adding 5 to both sides. The end result, though, is that y is going to be equal to negative 2x minus 2. And this 5 goes over here, and now positive 5. And so now we need to work out those values because those are like terms, those are numbers, number values. Negative 2 plus 5 is the same as 5 minus 2. That works out 3. So the equation becomes y equals minus 2x plus 3. This is the equation of the line AB. So that's the answer again. But okay so far?
Yes, sir.
All right, good. So I've now got the equation of a line. So next thing they said, we have to write down the y-axis intercept of the line AB. Y-axis intercept is a C value when the equation is in the line y equals mx plus c. When the equation is in that form, the C is the y-axis intercept. We happen to have this equation of a line in that form, y alone as a subject. So this is your M. And this is your C. And just that, the question asks us for coordinates. Look over here now. Question is asking us for coordinates, which is a plural word, meaning you have to give both coordinates, the x coordinate and the y coordinate. The x coordinate at a y-axis intercept is always 0 because it is a point on the y-axis. And on the y-axis, the x value will always be 0. And so we're going to answer part E. Part E. And say the y-intercept or the y-axis intercept is the point 0, C. Because I said coordinates, so I have to show the x value there, which is 0. And the C is this value out here. All right, because this line is in the form y equals mx plus c. The equation of this line is in form y equals mx plus c. So the m is negative 2, as we know, and the c is this 3. So this coordinate at the y-axis intercept is 0, 3. And that's another answer again. All right, so this is an answer again. But all right with that? Very good?
Yes, sir.
Okay. Then we're moving on to part F. And part F is a write-down question, meaning no calculation is needed. It says, write down the gradient of lines that are parallel to AB. What you must know is that parallel lines have the same gradient, right? Write down the gradient of lines that are parallel to AB. So lines that are parallel to AB will have the same gradient as AB. Parallel lines have the same gradient. So I'm going to write it down like this. I'm going to put M and put these two little lines here to mean that the lines are parallel. I like to call it the parallel gradient. The parallel gradient of AB is equal to the gradient of AB. And the gradient of AB is just negative 2, so this is just negative 2. So any line that is parallel to AB will have a gradient of negative 2. All right, simple as that. All right, and that answers that one. Then we'll come to this one now, which is asking us to write down now the lines, gradient of lines that are perpendicular. I just like to call it the perpendicular gradient. So perpendicular gradient of AB. So this is it now. The perpendicular gradient of AB, I'm going to put a perpendicular symbol on it, is equal to the negative reciprocal of the gradient of AB. How is negative reciprocal rate? It is minus because it is negative. Reciprocal is 1 over the gradient of AB. So that's a negative reciprocal. This is the reciprocal, that is the negative. And so it's a negative reciprocal of AB. And then we have the gradient of AB. And the gradient of AB is -2. So we'll basically take this -2 and put it under here to see what that is. And we would get, in this case, the -1 up here. I'll take the -2 and put it under over -2. Then the negative will cancel. And we would end up getting half. But then as a quick way to do this calculation in words, I like to use flip it, means flip the one that you have. Flip it and change the sign. And the sign is whether it's positive or negative. So two lines that are perpendicular must have opposite signs. Right? If one of them positive, the other one must be negative if they are perpendicular. One gradient positive, the other one must be negative. So since the gradient of AB was negative, then automatically the gradient of the perpendicular line to it is positive. That's why we have to change the sign. And then it's also the negative reciprocal. All right. But to do this calculation with the -2, we can flip the -2 and change the sign. How do you flip the -2 and change the sign? Let's do it right here. So like you have the -2, and you want to flip it and change the sign. So you want to write it as a fraction. So I'm going to put the -2 over 1. So when I flip it first, it becomes 1 over -2. That's a negative value. And then I have to change the sign next. Change the sign of 1 over -2, it becomes a positive 1 over 2. And so that is the same way that we could get the half. Flip the one that you have and change the sign. Any way you want to look at it, any way you want to do it, the gradient is a half. That is the answer right there for the perpendicular gradient. So any line now that is perpendicular to AB is going to have this gradient. Remember also that the two perpendicular gradients, the -2 times the half, -2 and a half are perpendicular gradients. When you multiply them, the result is -1. So that's how you can test if you have the perpendicular gradient. By multiplying the two perpendicular gradients, the answer must be -1. The product of perpendicular gradients is -1. All right, so that is it. So this perpendicular gradient in this question is a half. But go to that. But okay?
Sir.
I'm trying to explain it as much as possible. But this is the last time, all right? Then we'll come to H. And to part H. Part H. Part H right here says, but to find the equation of a line, part H. Find the equation of a line that passes through this point and is parallel to AB. Those are the two key things. Remember, if you want the equation of a line, you must know two things about it. You must know the gradient and a point. In this question, they gave you the point that it passes through. They didn't give us the gradient directly, no. They gave us the gradient indirectly by telling us that it is parallel to AB. Because they're testing your knowledge, testing if you know that parallel lines have the same gradient. So this parallel line that we want, let's put it like this. This parallel line that we want, it passes through the point P, 3, 4. So we have one of the two things that we need already. It is parallel to AB. And so it has the parallel gradient of AB. So the gradient of that line that we want is a parallel gradient, which was -2. And that's all we need. We need a gradient and a point to get the equation. We have both of them. All right, so we're going to put them in the point gradient form for the equation of a line, what I like to call the BFF. BFF. So the equation of that line becomes y minus the y value at P, because P is the point that I'm using up here. equals, it's a parallel line that I want, I'm using the parallel gradient. That's a parallel gradient into x minus xp, because p is a point that we're using. And basically that is it. You put in these three values in that equation to get the final answer. So it becomes y minus yp. The y value at p is this 4 up here. So it's y minus 4 equal the parallel gradient for the parallel line is this -2. We'll put the -2 out here into x minus, that's the x minus, and then the x value at p is 3. That's at 3. And I'm going to expand this -2 over this bracket now. Be careful because it's negative, right? Some people are thinking of this focusing on the 2 and ignoring the negative. You cannot do that. You have to see this as one value -2 that is being distributed across this bracket here. All right? So ready now. So I'm going to leave this as y minus 4 initially equals -2, not 2, -2 times x, -2x. And then -2 times -3. -2 times -3 becomes a +6. A lot of people put the -6 there. Negative times negative is positive. +6. And then this -4 again, they're going to come over here and become a +4. And so we're going to get y equals minus 2x plus 6 plus 4. The 6 and this 4 is 10. So the equation of that line is y equals minus 2x plus 10. And that again is another answer. But all right with that? But good with that? Students?
Yes, sir.
All right. All right. So we're going to know the next part, which is now asking us, this is parallel line. The next part now is asking us for a perpendicular line to AB right here. That line. See? Let's say it is perpendicular to AB. So it has a negative reciprocal gradient of AB, or we can say a perpendicular gradient of AB, perpendicular gradient to AB, right? And it passes through this point. So they gave us a point directly, which you must have. And we need to have the gradient. They gave us the point directly, and we also need to have the gradient, but they gave us the gradient indirectly by telling us that it is perpendicular to AB. Let's write it up down here again. Let's set it up. So we want the perpendicular line to AB. And it must pass to the point Q negative 3, -2. So the point they gave us was -3, -2. Because it is perpendicular to AB, it has the gradient, perpendicular gradient, M perpendicular, which we worked out before as being a half. See, we worked out as a half up here. See there, perpendicular gradient. So any line that is perpendicular to gradient, any line that is perpendicular to AB will have that gradient of a half. So the gradient is a half. So we have what we need, these three things. Those three values going into the equation, the point gradient form for the equation of a line. So the equation now becomes y minus the y value at Q, because I'm using the point Q, equal the perpendicular gradient, because it's the perpendicular line I'm trying to find. So this is a perpendicular gradient, into x minus x value at Q, x value at Q. Is this -2 right here. And now putting in the values. All right. So the equation becomes y minus the y value at Q is this -2. So y minus first, but the y value at Q is -2. So this is a -2 right here. This minus here becomes a plus. All right. So that's really y plus 2 equals perpendicular gradient is a half. Weight of the perpendicular line is going to be a half into x minus the x value at q is this -3. So again, you have to put minus minus 3 and you close the bracket. And then this minus minus becomes a plus as well. And then there are multiple ways to simplify this down. Right? I can choose to take this 2 and multiply it across here by these 2 values. Or I can just keep the half and multiply the half across here. So we get the answer is going to be the same. Let me use the method of multiplying this across here by this, because it's a fraction. If this was not a fraction, as we did before, I could just multiply it straight in here. Doesn't really matter. The answer is going to be the same. Remember, this is y plus 2, and I'm multiplying that by a 2 now. So it's going to become 2y plus 4, and I multiply by 2, right? So it's going to become 2y plus 4 equals, I'm going to take the 1 and multiply it inside the bracket now, which is x plus 3. Now 1 times x plus 3 is x plus 3. Then now I'm going to transpose this 4 and get 2y equals x plus the 3 minus 4. It's going to come over as a minus 4. 3 minus 4 is going to be a -1. So not plus, it's a -1 and again. All right? -1. And then to leave y alone as a subject. So I can see the c and the m. I need to get rid of this 2. How do I get rid of it? I can multiply by a half all the values by a half, or I can divide through by 2. Whichever way. So multiply it by a half, we're going to get y. Multiply this by a half, we're going to get x. Multiply this by a half, we're going to get minus half. And this is the equation of perpendicular line now. Are you good with that? Are you okay?
Yes, sir.
Yes, sir.
The last part now is telling us on here that we have to draw the graph showing all the points and the lines described above. So all the points and the lines that we just did, I need to put them on this graph. Right? So make this over here like a smaller so we can work with it. So all the points and all the lines that we just did, we need to put them on this graph. So let me scale up the graph first. All right. Remember, this device, I can't draw a straight line with it. All right. So you have to bear with me. All right. I'm going to scale up the graph. So let's put these points. Let's scale up the graph. So here's 1, 2, 3, 4, 5, 6. That's -1, -2, -3, -4. And down is -1, -2, -3, -4, -5, -6, -7. Up top now is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. All right. Let's plot the points now. Let me use blue to plot the A and the B first. Remember the A from the beginning. Where is it? Where is it? Right here. -1, 5. So come back 1 and go up to 5. Right here's that point. All right. -1, 5 is right here. That's a point E. Then B is 5, -7. So on the 5, -7. So we're gonna go out to 5 this way, and then go down to -7. Go down 7, all the way down here. So it is this point down here. That is the point B. All right. We also calculated the midpoint. Remember, midpoint was this 2, -1. I'm gonna put on the 2, -1 now. which is right here, to -1. That is right here. Also, I have to write down the y-axis intercept, which was 0, 3. Remember that? The y-axis intercept was 0, 3. Right here. Let's put on the 0, 3 for the y-axis intercept right here. That is a 0, C. Y-axis intercept. We call this point M. I remember. We didn't give this one an M. Those are the points. So all we need to do now is use the ruler and connect all the way down to here. That straight line. I think that's it. Let's try see if we can do it again. So use your ruler, guys, and just draw one straight line all the way down here. And that would represent the line AB. Draw it with a ruler. Do not do it freehand like me. Use a ruler to do it. So that's the first line. All right, and then you're checking the consistency of it, meaning the graph and your calculations must match. And you can see that they match. Because, for example, we get the midpoint and the line does pass through the midpoint. We get the y-axis intercept and the line does pass through that 3 point. So we can accept that line as being correct. Everything is consistent. Calculations and the diagram consistent with each other. So the other point that was introduced in this question was a point P right here. And we drew this parallel line through it. All right. So the point P was coordinates 3, 4. 3, 4 is right here. Let me use a different color for that. Let's go for purple. So 3, 4 is right here. 3 up 4 right here. All right. Then we got a line through it where the gradient was -2. And as I said, a nice way to draw a line is to use the 1 point on the line and the gradient. Use the gradient to locate other points on the line. Use the gradient to locate other points. All right. So let's see how we're gonna do that now. So for this part, the line through P, the parallel line talking about. It passed through P and the gradient was -2. All right, so we have this point P on the graph right here. The gradient was -2. So what we can do, we can rise and run from P to locate other points on the line using the gradient, because remember, gradient is how you rise and run between points. So we can take this -2 and put it over 1. And then this will be the rise. And this will be the run. So we are rising -2, means that we are going down by 2. And if we're running 1, means that we're going to the right by 1. And we're starting at a point that we have, which is P. And this is going to be another point. All right, so let's do that with this now to locate other points. We're going to come down 2 and run 1. So this is us coming down 2, running 1 unit. So there's a point right here on the line. And from here we can continue. Rise 2 again. 1, 2, and run 1 to the right. That's another point on the line. Then from here we can continue. Rise -2 again. The negative means that you're going to go down and run 1 across. That's a point on the line as well. You can see that all those points line up. All those points line up. But let me show you something now that I didn't show before. So when the gradient is -2, and you put that -2 over 1, instead of making those multiple small jumps from here to here, from here to here, and then from here to here, and then from here to here, we make one big jump, you know. By, for example, this -2 is the same as if I multiply this by 2, or multiply this by 4, and multiply this by 4. It's the same as -8 over 4. Because -8 over 4 is still equal to -2. So if you use the -8 over 4, which is the same as -2, then this would be the rise, and the 4 would be the run. I was still starting at the point P. So instead of taking these like a small run, rise and run, we can take a nice big rise and a nice big run that is equal to the same gradient, and it's still gonna be on the line. Let's look at that. So I'm using the -8 and the 4. So it means that I'm gonna rise -8, meaning I'm gonna go down 8. Look, 1, 2, 3, 4, 5, 6, 7, 8. Then I'm gonna run 4. 1, 2. Well, I'm coming off the page. Let me use 6 then. Let's start use, but it's coming off the page. I want to make sure the value comes on the page. So we can use 6/3 instead. All right, let's use 6/3 instead. If the graph was extended out to here, then I could show you those values. So let me use the 6/3 instead. So instead of using 8/4, I'm going to multiply instead by 3/3 and get -6/3 and use this instead, because this is still equal to -2 gradient. That means that I'm going to rise -2, -6, and I'm going to run 3. Let's go now. Rise -6. So starting here again, rise -6. So we're going down by 6. 1, 2, 3, 4, 5, 6. Run 3. 1 to the right, 2, 3. It's going to take me right here. And you're going to see that it's the same line as before. Same line. Remember the points that we had before were here. Rise 2, run 1. Which was right here. Rise -2, run 1. Which again was right here. But I just do these two now. But I just put back these two now just to show you that really and truly it is the same line that will go like this. So instead of doing these mini jumps, you could just make one big jump from here to here using larger values, and that's it. But I go to that. That's a parallel line.
Yes, sir.
Looks parallel. These two lines appear to be going in the same direction. They are parallel. All right. Now, if we continued back this way, remember the y-axis intercept of this line was 10, you know. Right? This line, the y-axis intercept is 10. Right here. For the parallel line. Where are you, parallel line? Parallel line. Parallel line. See there? The C was 10. If we continued back and go the other way on this line, because look again, the gradient again is -2, which right as -2/1. But this -2/1 is the same as 2/-1. So instead of rising down and running to the right, we could rise up with this +2 and go up from a point, starting at a point, we could go up 2. And then this run negative means go back to the left 1. And end up with another point like that. That's if we want to go the other direction. So we're starting at this point and doing it, right? We go up 2, go back 1 to here. We could continue. Just like the graph is not there, but if we continue, sorry. If we continue, we go up 2 again and go back 1 to here. And this will be at 8, you know, because you have 7 right or so. 8. And this will be a y-axis, right? If your y-axis was all the way up here. And then we'll go up 2 again. And go back 1. I would have reached 10 on the y-axis right there. And all these points will be the same line. If the graph was large and you want to go up a direction, it will show you that the y-axis intercept is 10 and everything is consistent. All right, but let me continue. All right, let us continue. We want to draw the perpendicular line now, right? The perpendicular line. Where is it? Perpendicular one is this one right here. This one. pass through the point -3, -2. Again, we can use that, these two to draw the line, the point and the gradient. So you're going to put on the point and you're going to use a gradient now to rise and run to find other points. So I'm going to put on the point Q first, which is on the line. Q, -3, -2. All right, let's do that one in black. Oh man, I deleted some stuff. Let's do that one in black and green. All right, so -3, -2. It's right here. All right, so that's where the point is. Right here. And then the gradient is a half. Right? Let's look at it. Gradient is a half, right? So the perpendicular gradient is a half of the perpendicular line. That means we're going to rise 1 and we're going to run 2. Starting at this point. So we're going to rise 1 and run 2 across here to here. That's a point on the graph. We're going to rise 1 again. Rise 1 again and run 2 to here. We're going to rise 1 again and run 2 to here. Rise 1 again and run 2 to here. So all those points are on the same perpendicular line. Like that. That's a perpendicular line right there. And again, instead of doing half, 1/2, we could make a bigger rise and a bigger run. So for example, we could write this as 4/8. And then we would rise 4, run 8. Yeah, end up on the same line. But just that you're just making a bigger rise and a bigger run to be on the same line. So go over here, I look at it. Look at it over here. Starting again from this point, that we know is on the line. Want to rise 4, so to go up 4. 1, 2, 3, 4, and run 8. 1, 2, 3, 4, 5, 6, 7, 8. That's a point on the line, which is one of the points that we got a while ago. Right? So you could mark just these 2 points with a big rise and a big run. So rising 4, running 8. 4/8 is still a half. Instead of using half and making the small rise and small run, we could use the 4/8 and use a big rise and a big run. So anyway you take it, the line is still gonna be this line that we had a while ago, like that. Let me put down the other points. That's 0 and 1. Right, so the line is this. That's the line. Right? And we did it. It was a small rise and run with these points that we get to. As I said, we could have just used this first one and this last one. Then now to check the consistency of it. Remember that the equation is this, you know. That we're going to have a half, but the y-axis intercept is negative a half. So the graph is supposed to cut the y-axis at negative a half, which it does right here. Does it right here with the blue. Or the purple right here. That's minus a half. Y-axis intercept is minus a half. You can see it. Halfway between the 0 line and the -1 line is minus a half. Right here. So the calculation of the diagram match, so we can accept that as a correct diagram paragraphs. But all right with that? Very good?
Sir.
Yes, sir.
Very good. All right, so I'm going to jump now and I want us to do a couple of the past paper questions that I sent you. All right? I want to do a couple of the past paper questions that I sent you. Took my time on this one, might go a little bit faster on those, just to make sure that we clear them. All right? Just to make sure that we clear them. All right, so this one actually came off of, let me not say it. It's a question that we're gonna do. All right. It's not beyond the level of what we are doing in class. All right, so that is it. So this question here now gives us this diagram. And I basically change the question a little bit, right? Send this diagram to you. And I asked for a number of things. I don't remember what I asked. I think I asked for the equation of this line. Then I asked for the equation of this line. Then I asked for this point. Then I asked for that point. I think that's something like that. All right, but that is a diagram right here on the screen right now. So coordinate geometry. So let's say the aim is to find this point and this point. Key thing is that this point is a point of intersection of these two lines. So we can find the equation of those two lines and solve them simultaneously. Then we will find the point M. Then now, M is the midpoint between these two. And so M is the halfway mark. And the question is asking us for this. So what means that these two lengths are the same. So the question is, if we know this point and this point, how can we get this one? And a couple of persons did it and got it right by plugging values in a formula. But I'm going to show you a nice way to do it from the diagram. All right? I'm trying to look back at the question that I gave you in the class. Let me look back at it and see what were the sequence of questions that I asked. Let me see. So, right, I asked for the gradient first, gradient. I asked for the gradient of AC and the gradient of BD, these two lines. AC, the gradient of that one, and the gradient of this one. All right, let's go. So, the gradient A, I asked for the gradient of AC first, this line. So we're going to use these 2 points to get the gradient. Gradient is difference in y by difference in x, right? So I run. I'm just going to put the values there. So it's this y value minus this y value. I'm going to give you like a hint though, guys. Give you like a hint. When you get a diagram, you're going to use the diagram for your calculation. Remember, you must always think as if you're going from left to right. So it's like you're starting at this point and you're going up to that point. You tend to use the destination point minus the starting point in your calculations. If you're focusing on this line, you're going from left to right again. So this will be a destination point. That will be a starting point. Subtract them this way. Do this point minus that point to calculate the gradient. It's kind of easier. All right? So doing AC, I'm going to use this destination point minus this starting point. That's how I'm going to do it. All right? So I'm going to use this y value minus this y value for the difference in y. So it's going to be 4 minus this y value is a -1 over this x value minus this x value. That's going to be 9 minus a -1. Again, this minus is a plus, so that becomes 5. This minus is a plus again. 9 and 1 is 10. So that gradient is a half. That gradient is a half. All right, gradient of AC is a half. 5 or 10. Then part B, you want to the gradient of BD. All right, gradient of BD. But we'll have 1 point on BD. But we know that it is perpendicular. Question said it. They are perpendicular. Said it over here in the question. All right, where is it? It says It says right here, BMD is 90 degrees. See? BMA, sorry, BMA here is 90 degrees. So therefore means that these two lines perpendicular. So they have negative reciprocal gradient. So gradient of BD is going to be -1 over the gradient of AC. So flipping this gradient of AC and change the sign, or take the half and put it under there. Anyway you take it, you're going to get -2. Flip this and change the sign, it's going to become -2. Flip it and change the sign. So like you have a 2, like you have a 1 over 2, you flip first. When you flip, you get 2 over 1, and then you change the sign. Change the sign. Positive right now so becomes -2 over 1. -2 over 1 is just -2. That's why this gradient here is -2. All right, let's try to go step by step. So that's gradient of that line. So answer the first two parts. The next part now wanted, I think, the equation of each of them, right? Part C wanted the equation of this line. And part D wanted the equation of this line. All right. Then that's why I sent the question in the group. All right. Right. I want the equation of AC. So part C wanted the equation of AC. So to find the equation of AC, we need to know two things about it. We need the gradient, which we have up here. The gradient is a half. Gradient of AC. Gradient of AC is a half. And we also need a point. We have 2 points. You can use any one of them. I'm just going to use C. I'm going to use C, which is 9, 4. Or I could use A if you want. Same difference. Let's use A. Let's just use A. Just to get practice with the minus. That's why I'm going to use A. So we can practice when we have the minus. Correct thing to do. And then we want to use the BFF formula again, the point gradient form. Point gradient form for the equation of a line. Y minus YC, because we're using point C, equals the gradient of AC into X minus XC. So it becomes Y minus, now the YC is -1. So it's Y minus a -1. -1. That minus becomes a plus. Let's show this as a plus right now. And then that is equal to the gradient, which is a half, into X minus XC. XC, you know, is this -1 right there. And again, this minus minus becomes a plus. Right? Minus minus right here becomes a plus. So this then is really, come on. This then is really Y plus 1. Let's write it. Y plus 1 equals half into X plus 1. That's what we have. All right. And what I can do, I can take this 2 and multiply it across here by these two values. Since this is a gradient, a fraction gradient, multiply the denominator across over this side by those two values. And so it's 2 times Y and 2 times 1. So it's 2Y plus 2 equal, then multiply the 1 inside the brackets. It's going to be X plus 1. I'm going to take this 2 and transpose it and subtract it. So I'm going to get 2Y equals X minus 1. Because if I take this 2 and subtract it, I'm going to get 1 minus 2, and the 1 minus 2 is -1. Then I need to divide through by this 2, or multiply by half to leave Y alone as the subject. And so it's going to become Y equals half X minus 1 over 2. And this minus 1 over 2 is this Y-axis intercept of this line right here. Minus 1 over 2. All right, it looks correct. That's the equation of the line AC. I could have left this one too, no problem. Could have left this one as well. Could have used that as the answer as well. For AC, put AC on it. If we don't want the fractions. Then we're going to do BD now. We're going to do the equation of BD now. So line BD. Equation of BD now. What do we know about BD? We know pass through the point B, so we know the point already. It's 3, 6. And we know the gradient. We calculated the gradient earlier. It was -2 right here. The gradient is -2. I'm using this point and this gradient to get the equation. So the equation would be y minus yb equal the perpendicular equal the gradient to -2, yes, into x minus xb. Because y minus the y value at the b is 6 equal the gradient is -2 into x minus x value at b is 3 right here. So it's y minus 6 equal this minus times x is minus 2x. And -2 times -3, minus times plus, minus 2 times -3 becomes +6. Negative times negative is positive. So we get +6. Then this -6 comes over, becomes another +6. So we get y equals -2x plus 12. That is the second equation. That's the equation of BD. So we have those equations. The next part now wanted us to find the point M. So point M is the intersection of these two lines. So to find that intersecting point, we can solve those two lines simultaneously. Because that point M is on both lines. Right? That was part E to find the coordinate of M. Let's set it up now. I'm going to solve them simultaneously to find the point M. Let's do it like this. So at M, at point M, two equations valid. First equation was this one, 2y equals x minus 1. 2y is equal to x minus 1. And also at the point M, this equation also, this line also passes to the point M. So the two equations are valid at the point M. So y is equal to minus 2x plus 12. So y is equal to minus 2x plus 12. And so to find the point M, I just need to solve these two equations simultaneously. I can use a substitution method by the substituting this line is saying y is equal to right here for this y value. Sub it like that. That's not the only way to do it, but I'm just going to sub it like that. So I'm going to sub it like that, right? So I'm going to sub for y. That's why it's sub for y. I'm substituting for y as I've shown there. So right here is going to become 2 times all of this where the y is minus 2x plus 12. And that's going to be equal to this x minus 1. So solving that for x. So this becomes minus 4x. Then 2 times 12 is 24. Equals x minus 1. Then this 4x goes over here and add to this x, 5x over there. So this minus 1 comes over here and become a positive 1 to give me 25 over here. So. And if we divide both sides by 5, cancel out this and leave x as a subject, then x equals 5. Anyway, we want to look at it, x is going to be equal to 5. So we can say, therefore, the x is equal to 5. I know that x is equal to 5. We can take this 5 and substitute it right here in that equation to work out what the y value is. All right? So we can say x equals 5 and we sub it in here. The y is going to be minus 2 times that same 5 plus 12. This negative 2 times 5 is negative 10. Negative 10 and 12 is 2. Same as 12 minus 10, that is 2. So the y value there at m is 2. So this is the x value, and this is the y value at the point m. So therefore, m is the point. 5 is the x value, 2 is the y value.
Sir,
Yes?
good question. Aside from the simultaneous equation, is it it's okay if you use like probably the gradient to calculate it?
Gradient. Yes, you
Yeah.
could use gradient. Yes, you could use a gradient. Yes, because you know the gradient of the line. So you know the gradient of the line. Yes, you could use a gradient. So because you know the gradient of this line, you could call this point, for example, if you call this point, for example, AB, they could use a gradient. But I think the simultaneous equation is the way that most persons would do it. But yes, the gradient could work as well. Could use a gradient. Because you know the gradient of this line, you know the gradient of both lines, so you could use a gradient, yes. But I think simultaneous equation is the better way to do it. But gradient can be used. Yes, that is correct. All right, gradient can be used. All right. So now that we know these 2 points, I know this point. Well, look at this now, guys. I know that point, and I know this point. Let's look at the diagram now. So this point is now 5, 2. I'm going to put it on 5, 2. But pay attention. And this is the midpoint. This is halfway between here and here. And I'm now trying to find this point, D. All right? Look, I'm going to do it easy now. Look. So remember that, let me use the red ink and show you. This length is the same as this length. Right? From here to here is the same as from here to here. Because M is the midpoint, right? So those two lengths are the same. What it means, guys, is that the change in the x value from here to here is the same change to this x value now. What happened to the x value? It increased by a 2. So it will increase by 2 more again. So right here, the x value is 7. Understand that? I know persons calculated and got it right, But that is it. X value there is 7. Do you understand what I just did?
Sir.
Yes? You understand it?
Sir.
I hear sir. I want to hear yes or no.
Sir.
I say yes.
Yes, sir.
Okay, good. So because this length and this length is the same and is on the same line with the same gradient, then the change in the x value from here to here, the x value must change by the same amount to here. X value changed by 2, which is a plus 2. We added 2 to the x value. So if we add 2 more again down here to the x value. So x value right here, so it's 7. And let's look at the y value now. Let's look at the y value now. Similar sort of stuff. The y value from here to here. The change in the y value. The change in the y value from here to here must have the same change down to here. Or did the y value change from here to here? It decreased by 4, so it's a subtraction of 4. So from here to here, you're gonna have to subtract 4 again. So if you have 2 right here, so you subtract 4, you're gonna become -2. So that's the point, 7, -2. And if you're not sure, you can calculate the midpoint. You can calculate the midpoint using these 2 points. And calculate the midpoint, it has to be equal to that. So in other words, if you average this and this, look at it now. Average them, it's supposed to get 5, see? 3 plus 7 over 2 is 5. 5. And if you average the y values, 6 and the -2, average them. 6 and -2, that's 6 and this -2. 6 and -2 over 2, that's going to become 4 over 2, which is 2. y validate this 2. So it shows at this point D is correct. And that's the easy way to do it. All right, so that is it. In terms of presenting it as a solution, I would maybe mark on the graph. If I'm in the exam room, I'm going to mark on the graph and I'm going to do something like this. This to this. Make the pen a little smaller. Just for the example, just so you will get it. This to this is a +2. This to this is a -4. So this to this has to be a +2 again. And this to this has to be a -4 again. Right? And then instead of just writing down the 7, I might write 5 + 2 first. And then this 2 - 4. 2 - 4. And my final answer will be 7 - 2. Just to kind of show some working, how I get it on the diagram. And sometimes some simple things I have to explain, you know. So I just use the diagram to show it. So I'm writing out all of this change from changing X from B to M, the same change from M to B to D. Changing Y from B to M is the same change from M to D. I'll let the diagram do the talking for me. And that is it. But I go to that. So the answer for D is
Yes,
this.
sir.
7 - 2. All right. So I know some persons actually calculated it and got it right. 7 - 2. But I'm showing you this nice, easy way to do it. All right. Then I also gave you this question right here, guys. I did. This question right here. I gave it to you today. More maths equals better maths every time. So I gave you this question to the last night. Nice, easy question. All right. So let's do it right here now. This is a worded one. All right. And then there are a couple of that we're going to look at as well. So A is a point. This one. This point is A. And then this point is the B. And then this point is the C. I'm going to rewrite them so I don't mix them up, right? Let's rewrite them. So A is a point 2, 5. And B is a point 5, -1. And C is a point 8, 6. All right, C is a point 8, 6. First question wants us to find the coordinate of the midpoint of AB. So averaging the coordinates of these 2 points. Let's call that point M, midpoint M. So part 1. M is the average of the 2 x values, this and this, you average them. So it's 2 + 5 over 2, and the average of the 2 y values, this and this. Average them. That's 5 - 1 over 2. So therefore, you simplify your values. This is 7 over 2. You can put 3.5, I can put 7 over 2. Simplify. This is 4 over 2. Because the 5 - 1 is 4. 4 over 2 is 2. So I'm going to write 2 right here. I'm going to write 2. That's my midpoint. All right. The next question says, part 2 says, find the equation of a line through C. All right. Let's sketch it. And it must be perpendicular to AB. So look what we want now. We want a line, a perpendicular line to AB. To AB. And it must pass through C. And the C is 8, 6. So remember, guys, to find the equation of that perpendicular line, we need a gradient of it. We have the point already, what we need is the gradient. So we need a perpendicular gradient to AB. All right, so let's look at it. So the gradient of this line that we want, the gradient of the perpendicular line is -1 over the gradient of AB. Let's do it right here. We can say, where the gradient of AB, let's work it out. We need to work out the gradient of AB because we don't have it. Where the gradient of AB, that we don't have right yet. We're going to work it out now. Using these 2 points, A and B. The difference in Y by difference in X. All right. Let's say I'm going to use this point minus this point to do it. This point minus this point. So I'm going to do this y value minus this y value. That's -1 minus 5. -1 minus 5. That's the difference in my y values. That's my rise. Overrun. This x value minus this x value now. It's 5 minus 2. So this up here becomes a -6. And 5 minus 2 is 3. 6 over 3 is 2. So it becomes a -2. So that I'm taking the -2, I'm putting it on here. Or I can just do this calculation as flipping this one and change the sign. So anyway, take it, the perpendicular gradient is equal to half. So therefore, we are using now this perpendicular gradient. I'll highlight them for you. Using this gradient and this point to get the equation. That's what we need, gradient at that point. All right, so the equation becomes y minus the y value at the point is 6. Let me write it out. YC equal the perpendicular gradient into x minus xc. xc. So it's y minus the y value at c is 6 equal the gradient, the perpendicular gradient we're using, you know, not the original gradient of AB, you know, the perpendicular one, which is the half, into x minus the x value at the point is 8. X value at c is 8. And since this half will simplify this 8, I'm just going to multiply the half inside this bracket as is. So y minus 6 equals half of x is half x. And half of -8 is a 4, -4. Then this 6 goes over and become a +6. And so it is y equals half x. Y a +6. 6 minus 4 is 2. I'll get a +2 over there. That is the equation. That's the answer right there. Half x plus 2. Oh, there's almost write it in this format. In other words, write it in this format, everything on the left side. So when we transpose everything we have over onto this side, and we're gonna get, come on, we're gonna get, carry this x over here, we'll get minus half x. Plus this y is already there. Take this 2 and carry it over, it's gonna become -2 equals 0. If we don't want that fraction, we can multiply it by a 2. All right, or even a -2 to make this become positive. So we can multiply it by a -2. I mean, if you give them this, is still right, you know, guys. This is still an answer, you know, that they have to accept. But they did not tell that the A, B, and C must be integers or anything like that. So if you give them this as the answer, you're good. But I'm just saying, if they gave you that the A, B, and C must be integers, then what we could do is multiply it by a -2. And then this will become a 1, which means that the equation will become x right here. Multiply this by -2, I will get -2y. Multiply this by -2, I will get +4. Multiply this by -2, it remains 0. Okay, could give them that as well as the answer. But I write to that. Very good.
Yes, sir.
All right. I want us to go now and do a couple of the past paper questions that I gave you. All right. I want to do some of the past paper questions that I gave you. So let me see which one it was. All right. I think I gave you January 20. 19. I gave you that one. January 2019 is in here somewhere. All right, we'll find it this way. This is June 2019. I think we're June. Ah, let's find it. I'll find another way. Hold on, let's see. January 2019. This is it. All right, which question I gave it to do? The coordinate geometry question. Coordinate geometry question, number 4 or so. Let's see. Things for the diagram 1. Give you to do. We're gonna work that now. I'll give you all of this question to think. All right. I gave you all of question 4, yes. But I looked at it and I saw the function and I said, let's just practice some function. More math equal better math. Right, let's do this quickly. This question says they give us this function, it's a rational function, as you can see. And it asks us for the value of x for which it is undefined. Remember, it is undefined when the denominator equals 0. All right, undefined when 5 minus x becomes equal to 0. That is when, how is this equal to, if the 5 equals 5, if x equals 5. So that is basically when x equals 5. That's the answer. See? Find the value of x. That value of x is 5. To make the function undefined. In other words, 5 cannot be in the domain. Function cannot work when x equals 5. As it will make the function undefined. That's the answer. Nice and easy. They want h to the minus 1. So we're doing the inverse of this thing. All right, let me write up here first. It is h equals 2x plus 3 over 5 minus x. I'm going to inverse this out. I'll copy it down. I'll move it down. That is it. I'm going to inverse it now. Bam. The h becomes x. And each of these x's become h to the minus 1. All right, so it's 2h to the minus 1 plus 3 over is a 5. 5 minus h to the minus 1. So we need to expand this out into separate terms. So the first thing is to take this denominator and multiply it across here by the x. So remember the x times this 5 first, which is 5x. And then the x times minus h to the minus 1 is minus x h to the minus 1 equals 2h to the minus 1 plus 3. All right. Then now we need to get them on the same side. And I want to transpose over here, but because this one is negative, I'm going to transpose over there this time. I'm going to take this over on the right side. I'm going to take the 3 over onto the left side. Let's move this 3 first over here. So I'm going to get 5x minus 3 that comes over equals, this is already over there, just 2h to the minus 1. This one that goes over there becomes a positive, becomes plus x h to the minus 1. Then it's a factorize h to the minus 1 now. I'm going to get 5x minus 3 equals h to the minus 1 into 2 plus x. 2 plus x. I'm going to take this 2 plus x and divide it under here. And I'm going to get h to the minus 1 equals to 5x minus 3. And this coming under here. Divided over 2 plus x. That is the answer right there. This is e to the minus 1 of x. This is the answer. This is the answer. Inverse function. All right. Then we come to the graph, which is what we really want to do. All right. So I'm going to show you now when you're doing these questions, right? And they actually give you the diagram and the graph. A lot of calculations they don't have to do any. You don't have to do the calculation. Some of the calculation you don't have to do. But the information is right there in the graph. Let me show you, for example. The first question is asking us for the gradient. Right here. What some persons do, they wrote the coordinate of this point, which is 5, 0. 5, 0. And they wrote the coordinate of this point, which is 0, 4. 0, 0, 4. And they proceeded to calculate difference in y by difference in x. But in this case, you don't have to do that. You can count the rise and count the run. From here to here, you can count the rise and count the run. So to go from this point to this point, remember, always think as if you're going from left to right. You have to rise down here. This is the rising coming down. That is the rise. And the rise is -4. Okay, it came down 4. See the 1, 2, 3, 4 units it came down. And then going across here, this way. That is the run. How many units you run? 1, 2, 3, 4, 5. You run 5 units. So my gradient is simply rise over run between 2 known points, which is -4 over 5. Done. But I go to that. When you have the graph, you can count out the rise and count out the run between 2 known points. But okay with that?
Yes, sir.
And if you ask me for the equation, you don't have to calculate nothing either. Because then this is the y-axis intercept right here. That is the c value. The c is equal to 5, no, 4. This is 1, 2, 3, right here is 4. So the c is equal to 4. So this is the m. I put the m on it. This is the m down here. The gradient m. And this is the c. So if you ask for the equation, you just need to write it down. If they ask for the equation, see the equation. You have to calculate nothing. The m is -4 over 5, and the c is equal to 4. The equation is y equals mx plus c. You don't have to calculate it. That's what some persons calculating, they don't. As yes, the graph is showing you the c, and it is showing you the rise over the run. So this is the gradient -4 over 5, and this is the c. All right, so the equation becomes y equals -4 over 5x plus 4. No calculation needed. This is 1 mark for it. No calculate, no. Then this one says the equation of a perpendicular, equation of a perpendicular line through P. All right, the equation of the perpendicular line through P. Now P is this point down here. So the line that they want is this. They want a line that goes like this. I don't want to draw it randomly, you know. So the gradient, watch this now, the gradient is supposed to be the negative reciprocal of that. So this perpendicular line is in the perpendicular gradient. So the gradient of that line, the perpendicular gradient, is going to be -1 over the original gradient of the first line. Let's call the first line M1. Gradient of line 1. Let's call it M1. All right, let's call it M1. And so that becomes equal to the negative reciprocal of this becomes 5 over 4. All right, and it passes through the point P, and the point P is, what is it again? 5, 0. This point is 5, 0. So we're using this gradient and this point to get the equation. So it becomes y minus the y value at P is 0. Y value at the P is 0. So I'm going to write y minus 0 equals the gradient, the m, which is the gradient, 5 over 4. into x minus x value at p. X value at p is this 5 right here. I'm gonna put the 5. That is it, because this is just y. So it's y equals 5 over 4x. And this time this give me negative 25 over 4. That is it. Can leave it at that. Are they okay with that?
Yes, sir.
All right. And it's done. That is it. Nice and easy. When they give it a graph, the question becomes that much easier to do. A lot more easier to do. When they actually show you the graph, you can count off stuff and see what is what. The next one I gave was May 2017. Let's look for it. May 2017. It's in there somewhere. June 2017. That was June 2017. All right, 2017. Put the CSEC on this. All right. Paper 1. All right, Mr. May. All right, see there. That looks like it. All right, which standard I give it to look? Let's see. I think there were number 4 as well. All right, section 2. Let's see. Somebody can remind me what question it was? And the 2017 paper. Aha, there you go. That's it. That's the one. That's the one right there. 4B. 4B. 4B, 4B. This one. I like these questions, you know, you can see the lines on the graph and you can count off stuff. All right, watch this now. Look at this one now. Again, you don't need to calculate, but the graph is there. All right, you don't have to calculate. You can see the points and count off your gradient and so on. So the graph below shows two straight lines, L1 and L2. L1 intersect the y-axis at 0, 1. That's a C value now. Right here, 0, 1. So you know that this, for the first line, the C is 1. Because it's 2 lines, I want to call it C1 and C2. So this right now, C1 is 1. And for this one is 6. The second line for the line 2, C on line 2 is 6. All right? So we have the two C values already. All right? To get the equation. Then it says the intersect. So line 1 intersect the y-axis at 0, 1. All right, line 2 intersect the x and y-axis at 12, 0 and 0, 6. So they gave us these 2 points of line 2 here and here. That's 12, 0. All right. All right. First part wants us to write the gradient of the two lines. Line 1 and line 2. Let's look at it. So line 1, I just need to see 2 points. First thing, I check the coordinates. The intervals. These all increasing by 1. So every box is 1 horizontally, 1 unit. And vertically, every box is a unit as well. What is now? Line 1. I just need to look at 2 points and count the rise and the run. Like for example, this is line 1. I'm going to look from here to here. And I'm going from left to right. My rise is 2 units. And my run is 1 unit. It means that the gradient is 2 over 1, which is 2 for line 1. Simple as that. You have to calculate nothing. It's on there. Count it off. Look at this one now. I use any 2 points on this line now. Let's say I'm using this point and this point. Again, I'm going from left to right. To go from here to here, 2 known points. This is 1 unit down. So -1 is my rise. I go this way 2 units this way. So my gradient on line 2 is rise -1 run 2 minus 1 over 2. I'm leaving these on my diagram and I'm going to write them down on here. The gradient of line 1 gradient of line 1 is 2, gradient of line 2 is minus a half. Done. Quick and fast. But you see that? You don't have to know use the difference in whatever difference in x because you have the graph there. You are able to count out the rise and count out the run. Just make sure that the unit, like for example, here is 1 unit, which it is because this is 7. From 6 to 7 is 1 unit. Make sure that, for example, here horizontally, this is also 1 unit, which it is. This is 3. Between 3 and 4, right here, is 1 unit. So every box is a unit, either direction, vertically or horizontally. So you can count out the rise and count out the run, and put the rise over the run. And remember, you always think of it as if you're going from left to right. But understand that, so I move on.
Yes, sir.
Good. And if you ask me equation, but good again. Tell me equation of line 2. For line 1, sorry. So for line 1, my gradient of line 1 and my C on line 1. I have both of them. Gradient of line 1 is 2. And the C on line 1. The C on line 1 is 1 right here. 1. The equation is y equals mx plus c. I'm talking about line 1. Put in the values. Y equals 2x plus 1. Done. You don't have to calculate nothing. The information is right there in front of you on the graph. You don't have to calculate none. That is it. You don't want the equation of line 2, I could do it as well. Line 2. This was line 1. All right? If I wanted line 2, I could do it as well because the gradient of line 2, I have it. It is minus half, right? Minus half. And the C on line 2 is 6. So for line 2, minus half is the gradient, and the C on line 2 is 6. So the equation will be y equals m, which is minus a half, x plus 6. If they wanted line 2, if the question wanted line 2 right here. We only wanted line 1. This one says no. What is the relationship between line 1 and line 2? Give a reason. They are perpendicular. You must say that from these two gradients. If you multiply them, they equal -1. So they are perpendicular. That's the relationship between them. They are perpendicular lines. These two gradients are negative reciprocal of each other. That's it. They are perpendicular. So the relationship between line 1 and line 2 is that they are perpendicular. Give a reason. Perpendicular gradient equal -1. So line 1 is perpendicular to line 2. Reason. The reason is that m1 times m2, which is equal to 2 times minus half, is equal to -1. When the product of gradients equal -1, then perpendicular. That is it. But I understand that? What are you going to do with that?
Yes, sir.
Yes,
Simple as-
sir.
All right, beautiful. Give you another one to do. No math equals better maths. So remember, the diagram ones are very easy. Let's look at 2022. I'll give you one for June 2022 to do as well. Let's find it. Let's say June 2022. Where is this one now? Gave you one on this paper to do as well. 2022, right? Where is it? Where is it? Right here. Give you this one to do. Diagram one again. All right. Question says, write the equation of this line in form y equals mx plus c. So we need the m and we need the c. So they give us the line L now. That is it now. See? Line L is shown on a grid. So you check the scale first. Every one of these boxes is 1 unit horizontally, 1 unit vertically. To get the equation of y equals mx plus c, I need the m and I need the c. I can get them off the diagram. The m, I'm going to counter the rise and counter the run between two known points. Like for example, two known points like here and here. You can see those points clearly. Going from left to right. I have to rise 1 unit and I have to run 3 units. So this is my rise. This is my run. So I have to calculate nothing. So the rise over run, gradient is 1 over 3. See? Rise over run. Put it there so as well on the diagram. So the gradient is rise over run, which is 1 over 3. So my gradient is 1 over 3 right here. The my C value is right here, so we cut the y-axis. C equals 1. So the equation is y equals 1/3 x plus 1. 1/3 x plus 1. That's the equation of that line. Easy, quick and fast when I give you the diagram. The information is right there on the diagram. You don't have to calculate. When the information is there. It's counter the gradient. The rise counter the run. And you can see the y-axis intercept. You have to calculate nothing. What else I want us to do? It says the equation of another line is this. It says write down the coordinates of the point Q. We're going to graph of the x-axis. I can draw this line on the graph, but the gradient is -2 and the y-axis intercept is 8. Let's draw it. Look at it again. The y-axis intercept is 8 and the gradient is -2. This gradient of -2 is -2 over 1, which means rise -2, run 1. But watch what I can do now. I can make this bigger and put it as -8 over 4. How did I get that? Multiply this by 4. I multiply this by 4 as well. Just to have a bigger rise and a bigger run. This is still equal to -2. All right? So I'm going to draw that line and show you that line. And then show that the calculations is consistent. All right? So I'm going to rise -8, run 4 from my y-axis intercept of 8 because y alone is the subject. All right, see it here now. Starting at the point, use the purple for that one. Starting at the y-axis intercept of 8. I can rise -8 down to here. That's 8. -8 gonna take me down to 0. Run 4 out to here. So this point is on the line. So this point and this point on the line. Use the ruler and draw it and you get it. Or I can do the small rise and run and get the same thing. Look. I can do the small rise and run and get the same thing. So I'm going to rise -2 over 1, rise -2, run 1. Look, starting here. I want to rise -2, 1, 2, run 1 to here. I want to rise 2 again, 1, 2 down, run 1 to here. Then I'm going to rise -2 again, rise -2, run 1 to here. And then I'm going to rise -2, run 1, and say end up at that same point. So you know, that point was correct from the get-go. So look at this point right now. I've already found the point of intersection of the two lines right here. The point of intersection of the purple line that I'm going to draw now and that original black line. So this is the line that they just told me about. I'm just doing this extra work to show you now, if they wanted to draw it. So I've drawn the line. This is the line Q. y equals minus 2x plus 8. That just told me about. But the question asks if I know, they asked us for, they said, write down the coordinates of the point where the line Q crosses the x-axis. That's 40 right here, saying 40. We cross the x-axis. 40. You have shown me that. So cross the x-axis at 40. I'm so write it down. Write it down. So I can just write it down. I've drawn my graph. The graph shows me I can write it down. But I can also calculate it. Because on the x-axis, y equals 0. On the x-axis, I know that the y value is 0. So I can put the y equals 0 in the equation right here and calculate the x. If I do in that method, y equals 0 on the line y equals minus 2x plus 8. I mean that on the x-axis, this thing equals 0. Right? So on x-axis, minus 2x plus 8 is going to be equal to 0. Transpose the 8, you're going to get minus 2x equals minus 8. And then divide by this negative 2, you're going to get the x equals 4. And so the point has this x value and this y value. So the point is 4, 0. But you see that just draw the graph and just write it down. It's easier. I quickly sketch in the graph, the line, and you see we cut the x-axis. See the point is 4, 0, rather than do all this calculation. Either way, the point is 4, 0. But I say that. But I can say that. But I'm showing you now the power of gradient. We can use the gradient now to find points and make your work easier to do. Start at the y-axis intercept, use the gradient to find all these other points. And you see that we'll cut the x-axis is this one. And we never have to calculate. Just use the gradient to count all the points. See where those points are. Next part says, write down the coordinates of the point where Q crosses the y-axis. That one easy. It is that 0C up here. 0, 8. So just write it down. See? Write down means I don't have to calculate nothing. You can just write it down. 0, 8. You all right? 0C. Write that, then good. All right. Next one says, on the grid, draw the graph of line Q. We draw it already. So you don't want us to draw it. I drew it from the beginning. So this was already done. Done that already, right? Draw it. So draw it up here. That's purple line there. Line Q. All right? Draw it already. And they said, according to the graph, the solution of a system of lines of L and Q is a point of intersection. That's what they mean. System of solutions of the equation of line L and Q. In other words, what is the point that is common to both of them, L and Q? This point that I marked in green is a point that is common to both of them. L and Q, both of them pass through that point. See, L and Q, both of them pass through this point. So that is the solution point for those two lines. That point is 3, 2. 3 is the x value, 2 is the y value. This point right here. 3, 2. Sorry about that. I've gone too far. 3, 2. This point. Then green. Questions asking us for this point where the two lines intersect. 3, 2. Let's write it down. It's on the graph. Let's write it down here. 3, 2. Point of intersection. Point of intersection. Of L and Q. That point. But all right. But good?
Yes, sir.
Yes, sir.
All right. So hope you're learning some additional stuff from this exercise here now, right? So when you get the graph, a lot of the work easier to do. All right. That's why I wanted to show you that power of gradient. How gradient can be useful. But a person just feel like gradient is something to just calculate. No, you can actually use gradient. All right. That's 2022. Then I gave you 2024. One last question and then we'll finish for today. It's now after 1. I don't like the Saturday classes to be too long, you know, because I don't want persons, because they're online, I don't want anybody to, you know, lose focus. So let's just do this last one and then we'll call it a day. 2024. This is January 1 or June 1. I do it. Let me see. January or June. This is January, no, this one. January 2024. Let's see now. Let's see now what that question is. I don't remember. Let me see. Let's see. I don't remember what question it was. Let's see if I can find it. Maybe section 2. Oh yes, I remember it now. It was a graph, but just the 2 lines. Just the 2 lines, no grid. I remember. There it is. There it is. All right, there it is. Still do not have dollar calculation with this guy. We don't. All right, we don't. Can still count off stuff even with this. All right, even though there's no grid. So the diagram below shows the graph of 2 functions, 2 lines, right? On a pair of axes. These lines, the lines G and H are perpendicular. See, they're perpendicular. This is G and this is H. What do I want us to do? Determine the equation of G, this one. I need the gradient and the y-axis intercept. Y-axis intercept is there already. So I already know the equation is going to be y equals mx plus c. Already I know the c. The c already is 3. Question is, what is the m? I can count it off from here to here. What is the rise and what is the run? I don't have to do the run first. I don't have to do the rise first. I can see what the run is. I can run, come out to here. So this is the run. So I run 6 units and then I rise 3 units up to here. So the gradient of G is rise 3 over run 6. Run to the right and I said run positive. And again, you must look at this gradient and know that the gradient is, the line is sloping upwards. So it must have a positive gradient. It's 3 over 6, it's a half. 3 over 6 is a half. So if I have to calculate nothing else, the m is a half. So the equation is y equals half x plus 3. Done. Some people calculating using the coordinates and all that. When you have the graph, you can just count the rise and count the run. When you can count it, you count it. Might I go to that?
Yes, sir.
Good.
Yes, sir.
A lot of people do it and get it right, you know, guys, but you just do it using a method that was not the easiest way. I wanted to learn to do it the easiest way possible. All right, so learn these other methods as well. Then now the next part wants the equation of H. All right, the one equation of H. Look at H now. We're not seeing the y-axis intercept, but we'll see this point. And we can't get the gradient because it is perpendicular. And we can use this point. This point is the point 40, clearly, on the line. What is the gradient? The gradient of line H is -1 over the gradient of line G because they are perpendicular. So we do negative reciprocal of the half. I'm putting the half on the here. So we want the perpendicular gradient of a half, which is -2. Put this on the here is going to become -2. Anyway you want to do it, if you flip this and change the size, -2. So the gradient of this H line is -2 and it pass through this point. So using this gradient and this point. To find the gradient of any line, you need to know 2 things about it, the gradient and a point. All right, so we want to use this gradient and this point. All right, so see it here now. So the gradient of line H minus 1 over the gradient of line G, because I'm perpendicular. G is perpendicular to H. All right, to H. And the gradient of line G was a half. So this calculation, it becomes minus 2. Then also pass to the point 40. We'll put 0, 4 in it on the x-axis, so it's 40. This point is 40. So using the BFF now, gradient and point. So it's y minus the y value at the point is 0. 0 equals the gradient into x minus the x value at the point is 4. All right, so I'm gonna put the 4 and the gradient is minus 2. I'm putting it there. Minus 2. That's it. It just becomes a y. This is a minus 2x. Minus 2 times minus 4 give me a positive 8. That is it. Next part says no. Calculate the coordinates of point P. Show all working. P is the point of intersection of the two lines. Two lines intersect at P. See there? The two lines intersect at P. They want us to show working and calculate. So they don't want us to count off and stuff. So basically solving these two equations simultaneously. The half x plus 3 and the other one that we just got. All right? So we're going to say at P, y is equal to half x plus 3 on the G line, but also y is equal to that. Y is also equal to minus 2x plus 8. Right? But P is the point of intersection of the two lines. So if y equals this, and y also equals this, we can equate them. We can equate this equals that. Because y is equal to the same value on both lines. So we can write half x plus 3 is equal to minus 2x plus 8. Equate them, because the two y values are the same at the point P. So we can multiply by 2 to get rid of this half times 2. Let's show it. Times 2 to get rid of the half. Or times the 2, this becomes x. This becomes x. This becomes 6. This becomes 4x minus 4x. This becomes 2 times 8 is 16. Take this over here, add to this x. I get 5x, because this is a negative 4x, you know. When you carry it over here, so it's going to become a plus 4x. That becomes a 5x over there. When I take this 6 and carry it over here, it becomes a minus 6. So I get 16 minus 6, which becomes a 10. And so the x is equal to 2. When I divide by 5, x is equal to 2. Then if x is equal to 2 right here, then the y becomes half of 2 plus 3, right? So I can say, and the y is equal to half of 2 plus 3. When I take the 2 and I plug it here, so I'm calculating it. But also put it here, so if I wanted, you know. Anyway, take it. Answer is going to be the same, right? But that will be minus 4. Something is wrong. Oh, it's a 3 I must add. It's a mistake. I'm adding 2. It's supposed to be a 3, right? Just a 3. I just seen 2 different, but it's a whatever. This is actually a 3. So this is 4. That's a 1 plus 3 is 4. I'll put it here instead. I'll put it here instead. It will be minus 2 times 2 plus 8, which will be minus 4 plus 8, which is still 4. All right, so anyway, take it, it is a 4. That's a 4. So the x is 2 and the y is 4. So P is a point 2, 4. That's the answer right there. But all right with that, let's solve the two equations simultaneously. This is the G equation. This is the H equation. Let's solve them simultaneously. P is the point of intersection of the two of them. Very good?
Yes, sir.
All right. Anything else I wanted us to do? No, that is it. And that is that for today, guys. All right, so if you did the question, I didn't get it right, do it over. If you want, you can do it over still and try the method that I showed you, especially with the graph one. A lot of people calculated when they did not need to calculate because the information is right there on the graph. All right, so you can do the questions over. Those of you who did not do them, do the questions. I'm going to send the video in the group right at the end of the class. And as usual, persons who are not here are expected to go and watch the video. Starting a new topic from tomorrow. Next time we see coordinate geometry as a topic. Will be in revision, but we're still going to be applying some of these coordinate geometry methods for the next topic, which is linear programming. Inequalities and linear programming, mainly linear programming. All right, guys, so see you all in class tomorrow and Monday. It's going to be fun. Bye, everybody.
That's fair.
All right, bye-bye. I'm going to end it now. Okay, bye, 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 bye. Bye, everybody. Redo the questions. Bye, Elizabeth.